Students, welcome back for the second session of the videos related to the group technology. Now, in the first session, we have discussed about the concept of introduction to the group technology and what do you mean by part family and what are the methods of part classification and coding. And there we have understood three different methods. And in one of the method, which is called as part classification and coding, there is one very important classification system which has been widely followed, which we are going to discuss now, which is called as OPITS classification system. So basically, the OPITS classification system is the system which was developed by a person by name OPITS in Aachen, okay, which is in Germany. Basically, this classification system is intended for the machine parts. The basic structure of this OPIT classification system consists of totally 9 numerical digits and 4 alphabets. So basically, it starts like this. So 1, 2, 3, 4, 5, which we generally called as the forum code. 3, 6, 7, 8, 9, which we call it as supplementary code, and A, B, C, D, which we call it as the secondary code. Now, the code which is called as the form code is generally which is going to be used to describe the primary design attributes of the parts such as geometry. And supplementary code includes information relevant to manufacturing such as raw material and tolerances. And the last one, which is ABCD, called as the secondary code, which identifies production operation type and the sequence. So form code says about the geometry, supplementary code says about the manufacturer raw material tolerances, and ABCD, that is the secondary code, says about the operation type and the sequence. If you go further with respect to this, now, right, yeah. Now, on the slide, you can able to see the OPIT classification system, which is basically a complex classification system. So now here, I have just shown about how it's going to be with respect to the plus 5 digits, which is a forum code, and the supplementary code, right? Now, in the form code, if you notice clearly, right? Now, in the form code, we have digit 1. And please understand that the position of digit 1 can take any number from 0 to 9. Likewise, all the individual positions can able to take up the numbers from 0 to 9. So that is what it is to be understood. Now, in the first digit, the digit number 1, which is a part class, which says about the first 5 numbers, that is 0 to 5, is for rotational members, and 6 to 9 is for non-rotational members. That means if the position, if the first digit, if it is going to be 0, it means that it is a rotational member and L by D ratio of the part is less than or equal to 0.5. And if that number is going to be 1, the position, the first position, if the number is 1, then we should understand that is L by D is greater than 0.5 and lesser than 0.3. Like that, for all the L by D ratios, the numbers have been indicated. And next is going to be from 6 onwards, it is for the non-rotational parts, which we have discussed in the previous slide, previous video, that is called the aspect ratio. A by B is less than 3. That is, A is nothing but the width, B is the length, and C is the height. Now, the ratio of A by B, if it is less than 3, and A by C greater than or equal to 4, for that particular part, we will say the digit as 6. The code starts with number 6. So now all these are going to be the position for the first digit. Please understand, the first digit, which is the number 1 digit, can take any number from 0 to, can take any number from 0 to 9, right? The second one indicates the external shape elements. Okay, second one indicates the external shape elements. For the external shape elements also, there are various classifications are going to be there. Because of the complexity, we have just shown only the explanation for the first one. The next one is going to be, we should understand that the second digit is going to be about the main shape, external shape element. Third digit is going to be the rotational machining, internal shape element. And digit 4 is the plane surface machining, and digit 5 is the additional holes, teeth, and forming. And with respect to the next 4 digits, which we call it as the supplementary code, The supplementary code 6 is going to be the dimensions. So various dimensions are going to be there, which is this is the sixth position. Please again I'm telling, this is the sixth position. Sixth position can take any values from 0 to 9. So these dimensions have been divided into 9 types, which is from 0 to 9. Material, there are varieties of material, that is totally 10 materials from 0 to 9. And the eighth position or the eighth digit is the original shape of the raw material, and ninth one is the accuracy. So now in the exam you will be writing only this, and explanation is required for the first digit only, right? And continuation with this, now much more complication, I just try to give it to you. That is, the first digit you already understood in the previous slide. Second digit is says external shape. Okay, external shape elements. Now, as I said, the second digit can take any number from 0 to 9. Now, if you observe, the second digit 0 is going to be what? It is smooth, no shape element. That means it is just a shaft without any of the shape elements. Now, 1, 2, 3 is stepped to one end. Okay, that means there is a stepped shaft is going to be there. Step is going to be to one end. That is larger diameter to smaller diameter. That is step to one end. That is in that case, one is no shape element. That means both the steps are just a plain shafts. Then the number two is the code 2 is going to be there if the shaft is having thread. Number 3 is going to come if the shaft is having the groove. Similarly, if it is stepped to both the ends, step is there at both the ends, it means at centrally you have a larger diameter, to the left you have a shorter diameter, and also to the right you have a shorter diameter. That means step is on both the sides of the main shaft. Now digit number 2, that is the code 4, is going to be no shape element. That means what? The shafts are going to be what? Smaller shaft, nothing is there. Then larger shaft, nothing is there. Then a smaller shaft, nothing is there. Then 5 is on both the sides of the larger shaft. If the threads are going to be present, then it is number 5. And if grooves are present, it is number 6. Then next we have functional cone. Okay, if it is functional cone, then code is 7, and operating thread it is 8, and any other than the covered under 1, 0 to 8 will be formed under 9. Similarly, the same thing is going to be there for digit 3, but only difference is digit 2 says about the external shape, digit 3 says about the internal shape, similar to the digit number 2. Then digit 4 is going to be plain surface machining. Now, depending upon the surface machining, no surface machining 0, surface plane. Now, what we need to understand is, after observing the part, we need to identify where that part is going to fit into, according to the category under which the surface machining requirement. So you will be writing in the digit 4, in the location number 4, we are going to write any number between 0 to 9 depending upon the part criteria. Similarly, we have digit 5, which is auxiliary holes and gear teeth. So depending upon all these categories, we are going to indicate the number. Now this is what I just said, that the complexity involved in identifying the part and making that into the individual location, or making that into individual part family, will take larger amount of the time, right? That's about what is called as the OPIT classification system. Then the third method of the part family identification is what is termed as the production flow analysis, which we call it as PFA. Now, in case of PFA is the method for identifying part families and associated machine groups based on the required manufacturing process needed for each part. Now here in production flow analysis, we are going to we are going to identify the part based on the manufacturing procedure requirement. Based upon the manufacturing procedure requirement, we are going to identify the part. Okay. Then work parts. Now here, work parts with identical or similar routings are classified into part families. These families can then be used to form logical machine cells in a group technology layout. That means, in this case, the work parts which identical or similar routings are transferred into parts. So that means to say, each work part requires some machines in order to complete all the operation. Like that, for each of the work part, we will identify what are all the machines which are required to complete all the operation on a individual work part. Now, after identifying after noting down all the work parts from 1 to n, now then from 1 to n, we'll pick the work parts which require same type of the machine. Then those work parts will be segregated into what is called as a part family, by which those work parts require a specific type of the machine. So that is the case of what is called as a production flow analysis. Now, in case of production flow analysis, now there are important things are going to be there. Some steps are going to be there, which has been shown here, which is called as the PFA chart. Okay, PFA chart is production flow analysis chart. Okay, now this production flow analysis chart is an information for parts which is tabulated, which is known as part machine incidence matrix. So please understand this very carefully. So we have what are called as parts. The parts are identified by a subscript called as I, right? Then machines have been identified by a subscript called as J, right? Now, in this table, what I am trying to tell from this table is there are from A, B, C, D, E, F, G, H, I parts are there, and there are some 1 to 7 machines are there. Now, how you need to read is the part A requires the processing on machine 1 and machine 5. That means in order to complete part A, machine number 1 and machine number 5 is required. Similarly, in order to complete part B, machine number 4 and machine number 7 is required. So similarly, you have to read for C, D, E, F, G, H, I. Right. So one more. Now, in order to complete the part E, the machines required are 2 and 3. Now, this is the initial table that is known to us. Now, we'll understand how the processing is going, it should supposed to occur. Now, if you consider part A, okay, part A requires what? Requires only the machine number 1 and machine number 5. Now, just imagine if you process this part A on the machines 2, 3, 4, 6, and 7, will there any use to us is the question. Please understand, we will not going to have any use out of this, because A is not to be operated. A is not to be operated by 2 machine, 3 machine, 4th machine, 6th and 7th machine. Unnecessarily, we are moving the part onto those unnecessary machine, by which the time of production is increased, and the work in process is going to be larger. Now this we need to understand. Now what we need to do is we need to make out a plan. Okay, we need to make out a cluster. Okay, now how the cluster is going to be like that. If you observe carefully, observe the sheet that I am just showing now. Okay, right now here. Now here, if you just observe, now I just type out here. Now what we have is, we have machine number A. Okay. So machine number A requires what? Requires 1, 5. Then machine number B requires 4, 7. That is from the table that is from that incidence matrix I am taking. Machine C requires what? 3, 6. Right. Machine 3 requires 3, 6. Then machine D requires the first one, only one machine. Okay. Then machine A requires 2 and 3. Then machine F requires the processing on 4th machine and processing on 7th machine. Then machine G requires only one machine, which is 7. Then machine H requires 1, 1 and 5. Right. Then machine I requires 2 machine, so 3 machine and 6 machine. Now this is what is the requirement. Now if you observe carefully, right, the machines, well, first you just look at which are the machines which are common to the parts. Now if you observe carefully that the machine number 3, okay, so machine number 3, if you observe, okay, right, so machine number 3 requires what? 3 and 6, okay, and machine number E requires 2 and 3, right? So 3 and 3 is common. Then machine I requires 2, 3, 6. Okay. So therefore C, E, and I. Okay. Therefore, what are the three machines? Okay. C, E, okay, and I can be what? Can be grouped into one. Okay, now this is what? This is a group one activity. Then if you observe carefully, then A is 1 comma 5. A is 1 comma 5. Check, is there any 1 or 5 work element present? Okay, right? Now A is 1 5, okay, right? Then if you observe, this is 4 7, it is not possible. Then D is there, D is 1, D is 1, okay, 1 is here and 1 is here. And if you observe, H is also there, okay, H is what? H is again 1 comma 5. Therefore, A requires machine 1, machine 5. D also require machine 1. H also require 1 comma 5. Now, other than these three, so you don't need the other machines for these different parts. Therefore, if you observe now, right? If you observe, right? Now, A and D and what? And A, D and H. Okay. So A, D and H. Okay. Can be grouped into what? Can be grouped into second. Okay. Right. Similarly, if you observe, now we have made two groups now. Okay. Then we have left out with what? B 4 comma 7. Okay. B 4 comma 7 and F is also 4 comma 7 and G is 7. So 4 7 common, 4 7 common, and 7 is common. Therefore 7 is common among all the three. Therefore what now? Now B can be taken separately, F can be taken separately, and G can be separately. Okay, now this becomes what? This becomes group 3. Now what is that we are done here? Out of these so many machines that we had, okay, now we have grouped them into group 1 as CEI, group 2 as ADH, and group 3 as BFG. Okay, right. Now this is what is the important one. Okay, right. Now next is, now as we are just going through with that, now we'll come back to our the discussion of this. Okay, now right. Now you just observe. Okay, as I told in the previous slide on the whiteboard, so CEI can be made like this. Therefore, on CEI part, you just go with only 3 to 6. Therefore, 3 to 6 machine you take separately and process only CEI jobs, and take 1 and 5 separately, right? Take 1 and 5 separately the machine, and on this 1 5 machine ADH can be processed. Okay. Then 7 4 is there and FBH. Now you can observe. So using this pattern of data in the chart, related groupings are identified and rearranged into a new pattern. It is interpretation of the new pattern. Now, just as I said, parts C, E, I can be machined in a group of machines, which is 2, 2, 3, 6. Therefore, this forms what is called as a cell. Okay. Now understand, this cell, okay, this cell, which is a machine of 3 to 6, is capable of 3 to 6 is capable of producing CEI only. Therefore, CEI part will form one part family. Okay. Then the processing of this is very easier because you are not sending CEI onto any other machines. Similarly, so ADH will form one particular cell, and you require only the machines 1 and 5. Similarly, FGB, okay, or BFG, whatever you can say. Now, this forms one particular cell. Therefore, now what is that you have done? By production flow analysis, you understood that cells can be formed. Okay, cells can be formed something like this, so as to process some known type of the work parts. Okay, now this is the beauty of what is called the production flow analysis. Okay, right. Now, by observing the production flow analysis, what you understood is it is possible for you to make what is called as a cells. Okay. Now, as we understood in the very beginning, the group technology, the implementation of group technology leads to two important things, which was called as cellular manufacturing and flexible manufacturing system. Okay. Now we'll understand what do you mean by cellular manufacturing all about. Okay. Now, the cellular manufacturing is something where when the machines are grouped, the term cellular manufacturing is used to describe this work organization. So cellular manufacturing is an application of group technology, dear friends. Okay, cellular manufacturing is an application of group technology, and it's a portion of firms manufacturing systems converted into cells. Now there are plenty of other machines are going to be there, but we are considering only few type of the machine which we call it as the cell. Okay, so cell consists of few type of the machine which are responsible to produce a particular type of products. So cells are now on this, now please observe this carefully. Cells are dedicated to the production of a part or product family of a limited group of families. Therefore, cells are used for what? Cells are used to produce the cells are dedicated machines. Cells are dedicated machines which are mainly used to produce some type of the parts. Okay, please understand. I am not going to say that all machines are there required to produce the component. Some cells are there which are very much sufficient to produce the component. Now, what are the objectives or the advantages that you could able to gain out of cellular manufacturing is to shorten the MLT. Okay, MLT is going to, that is manufacturing lead time is going to be reduced just because that you are not asking the parts to move unnecessarily. As you are not asking the part to move unnecessarily, the work in process is going to be reduced. Okay, and you are doing it in a better way. So improvisation of the quality is going to occur. Production scheduling can be made simplified, and reduction of the setup time is going to be assured. Okay, right. Now then let us understand about the classification of the cellular manufacturing. Okay, so cellular manufacturing can be classified into single machine cell. So single machine cell indicates that you will be having only one machine which is dedicated for the production of a particular part, which is a rare case, okay, in the manufacturing sector or a manufacturing scenario. Then the group of machine cell with manual handling. Okay, as I said, cellular manufacturing is the group of machine with manual handling only, right? Then human operators for material handling function. The cell is organized into U-shaped layout. This is called as a U-shaped layout, wherein the work is going to enter here, and this is a machine, another machine, and 5 different machines are there, which is present in the U shape. Now the work is going to be done by the human labor. Human labors are going to be responsible in order to carry out the work, and the movement is also done by manual handling. Okay, now this is a case of the U-shaped cellular manufacturing. Then the group of cells with semi-integrated material handling. Okay. Now here you can observe we have what is called as a semi-integrated material handling. Now in the previous section, what we have discussed is material handling is done by the manual means. Now one more improvisation is that we are looking at now is improvisation is with respect to what is called as the how the handling is going to be done. Now here in this case mechanized handling is there. That means you can observe this to be a conveyor. Okay, now we have inline. This is called as an inline setup. Okay, this is called as an inline group technology layout. Okay, right. Now in inline group technology layout, as you know earlier itself, that the work parts are going to move in a straight line arrangement. Okay. Now these are all the machines which are going to be responsible. Then other method is going to be what is called as a loop layout. Okay, in this case of loop layout, the work part is going to what? The work part is going to move in a straight line and also in a circular fashion. Okay, now here you have loading and unloading stations are going to be there. Loading and unloading stations are there where you are going to load the work part. It's the starting work parts that you are loading, and once you are loaded, the work part will move in the loop, where in each of the loop you have the machining is going to carry out. MESCH is nothing but machining activity. Okay, machining is going to carry it out, and at the end you are going to unload the work parts. Okay, now this is a case of a loop layout. Okay, loop GT layout. There's one more thing which is interesting, which we call it the rectangular GT layout. Okay, in case of rectangular GT layout, you are going to load the work part. Okay, and loading is done by manual means. You are going to load the work part. Now if you observe, I told in the earlier section in the classroom, that is you have a circle and what is called surrounded by a circle, you have a rectangle. Okay, or a square. Okay, square and a circle. Okay, square and a circle is there. Okay, the square indicates what? Square indicates the pallets. Okay, pallets are nothing but the work holding devices, right? So the pallets have been launched. Within the pallet, the work parts are going to be present. The work part has moved here. Some machining has done. Work part has moved here. Some machining has been done. Some machining has been done. And after all the completion of the work, now here you are unloading the work parts. Okay. Now remember, you are only unloading the work parts. Okay, not the pallet. Now the pallets will come in the same loop. Okay, there is something called the return loop is going to be there. Okay, now what is going to happen now? The pallets will come back to the return loop, and these pallets are going to be washed by using the wash station, and these returning pallets will again can be used further. Okay, this is the case of what is called as a rectangular GT layout. Okay, now this is something related to what is called as your the group technology, which is nothing but cellular manufacturing. Group technology, application of group technology, which is cellular manufacturing. Okay, right. Now we'll try to just go with the end of the group technology, which is the application of group technology. Okay, now what is the first application here? Now GT allows similar designs to be easily modified from the existing design from the database instead of starting from scratch. Now what you need to understand here, assume that you have to design a new part. A new part has come to you. Now further you need to write the design history of that. Okay. Now the question is, are you going to write the design history from the beginning till the end is important. It is not required because already you have in your database, you have some codes which are going to be there for the parts which is already present in your factory. Okay. Now the new design which has come might be similar to the one which you have already done. Therefore, what you can do is take the one which you already developed. Please understand. Take the one which you already developed in your which is present in your database and compare that with the new design. Wherever there is some modifications is required, there you are going to work it out, and your design time, the time required for design is going to reduce. Okay, that is very, very important. Otherwise, if you spend more time in designing, then ultimately more time you are going to take in designing and then to manufacturing and then to production, and the delivery time promised to the customer, it may not be possible for you to meet. Okay, right. Second one is going to be standard process plans can be developed for the groups. Okay, right. Now the application of GT is standard tooling and setup procedures can be used because everything has been standardized. You know what type of machines you are going to use, and as you know very clearly what type of machines that you are going to use, for those machines you will be knowing exactly what is the requirement of the tools and what is the setup required for that particular machines. Then use of GT allows faster production, it is 100%, leads to less inventory and reduced work in process. Okay. Material handling is reduced, very much important because you are not making the work part to move unnecessarily. Therefore, material handling is reduced. Then improvement in quality and reduction in scrap, improved utilization of the machines because by making the cell, you are making all the machines to be working, to be contributing. Hence, the utilization is going to be very good. Okay, right. Then increase in output per employee. So that means the amount of production per employee is more. That means that there is an increase in productivity and improved ability to respond to market changes. This is very important. Any system that you are going to develop, it should be responsive to the market changes. If the demand for the market is there, then you need to respond positively to the market changes. If you are not going to respond positively to the market changes, then your system is not sophisticated one, your system is not flexible one. You can't able to make a business out of this particular type of setup. Now these are all the application of group technology, right? Then let us end with the limitations of GT. The limitations of GT, very important, is the cost of implementation is very generally higher, okay, because it requires more of the procedure. Then may not be suitable for a factory with a very large variety of products. Now please understand, if the factory is having a very large variety of the product, then it is not possible for you to make them into groups because very large variety means in each individual part will become a part family itself. Please understand. Okay, if all 100 are different, if all 100 parts that you are producing is different, The total number of part families present is going to be 100 only. It becomes what? All of them are going to be unique product. Okay, for that, if you implement GT, it's a useless affair. Okay, right. Then there are too many GT codes in use, and there is no one GT code that suits all application. Okay, now because basically the GT codes are going to be different, methods are going to be there. Accordingly, there are different GT codes which are going to be present. Okay, right. Then very important is the range of product mix in a plant may be under constant revision. That means the type of product that you are going to produce in a plant is not going to be a stagnant one. Remember this. The customer requires changes. Customer want changes. Okay, as you need to fulfill the need of the customer, very oftenly the product mix in the plant will be under a constant revision. As and when there is a constant revision happened within the product, some changes in the design of the product is going to occur. Then again, what you have to do, you have to rearrange the machines in order to make that to happen. Therefore, this limitation, which is the range of product mix in a plant, may be under constant revision, in which case GT cells may need constant revision, which is impractical. Remember, it is not possible for you to keep on changing the machines from here and there in order to produce the variety of the components. Okay, now these are all the limitations of the GT which is present. Okay. Now we'll just in a nutshell we'll understand what is that we have done in this today's exercise, in this second half of the exercise. So we have started our discussion with the OPID classification system. We understood there are something called a forum codes are going to be there, supplementary codes are going to be there, and secondary codes are going to be there. And we understood this, dear students. So this is very important from the exam point of view. So this is what you need to concentrate. This diagram you need to concentrate, and this one I brought to show you how the numbers are going to be generated. So this is not required for you to write in the examination, but understand what it is. Then we have what is called as PFA, that is production flow analysis, and about what is called as the incidence matrix and how the grouping can be done. Okay, right. Then we learned something related to cellular manufacturing and what are the different types of cells we have discussed: single machine cell, then U-shaped layout, and then we have inline shape layout, loop layout, and rectangular layout. Okay, and then we understood about the application of group technology and the limitations of group technology. Okay, now this is in a nutshell about a newer methodology of the production technology, which is called as group technology. Okay, so that's it for now. We'll just take a short break. Now we'll continue. I'll just get back to you soon with the video on the flexible manufacturing system. Okay, until that, stay safe. Goodbye.